Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. This is part 2 of my videos on incredible ice, and this week I'm going to be looking at density, heat transfer and melting. Let's check it out. In the last video, I looked at the different elements involved in water freezing and showed you how to pick up an ice cube with a piece of string and how to instantly freeze water. If you've not watched that video yet, go back and check it out because there is a prediction that I asked for an experiment I'm going to do in this video. So I'll put a link in the description to part 1 of my exploration of incredible ice. Before I look at that experiment I asked for predictions for, I'm going to show you something else that explores the density of ice and water. For this, I'm using a glass jar, some vegetable oil, some baby oil, and I have an ice cube which I have put some food colouring in so you can see very clearly on the camera what is happening. First, what I'm going to do is half fill my jar with vegetable oil, and then I'm going to squirt in baby oil to fill the jar up the rest of the way. You'll notice that the baby oil is floating on top of the vegetable oil, and this means that the baby oil is less dense than the vegetable oil. I've done quite a few videos previously that explore density, so I'll put links in the description for you to be able to go and check these out to get a detailed definition of what density is. Something interesting to note for this experiment that we're going to see is that water is more dense than vegetable oil, and that's why you don't use water to try and put out an oil fire, because the oil will just float on top of the water. You'll know that when you put an ice cube in water, the ice cube floats on top of the water, and this is because the ice cube is less dense than the water is. So now what I'm going to do with my jar is I'm going to take an ice cube that I've put food colouring in, and I'm going to drop it down into the jar. You'll notice that the ice cube is floating round about the middle of the jar. This means that the ice cube is less dense than the oil is. But it also means that the ice cube is more dense than the baby oil, and that is why it is floating in between these two layers. I'm now going to speed the footage up quite a lot so you can see what happens with this demonstration rather than watching it in real time, because this took almost an hour for the experiment to carry out from start to finish. As the ice cube starts to melt, you'll notice droplets forming on the bottom of the ice cube which drag it down a bit in that oil layer until the droplet falls off and the ice cube rises back up again. That droplet of water goes all the way down to the bottom of the jar. This is because, as I said previously, water is more dense than oil is, so oil will sit on top of water. But the ice cube is less dense than the oil is, which is why it's continuing to float. As the water droplets form, they are increasing the density of the ice cube, and that is why it's getting pulled down a bit in the oil. But once that drops off, the ice cube returns to being less dense than the oil, and the water drops right down to the bottom. You'll notice that by the end of this experiment, we have a layer of coloured water at the bottom, a layer of vegetable oil on top, and a layer of baby oil on top of that. I found this experiment absolutely fascinating when I first saw it, to see an ice cube floating in the middle of a liquid rather than on top of a liquid like I am used to. This is a great experiment to do at home to explore the density of different substances. Here we can see the density of 3 different liquids, as well as the density of one of those liquids when it is in solid form. So you could try this with lots of different liquids, freezing them, putting them into different combinations to find out what is more dense or less dense than the other things. And now it's time to explore that experiment that I asked for your predictions on. In front of me I have a metal baking tray and I have a plastic chopping board. What I'm going to do is put an ice cube into the middle of each of these and watch to see which one the ice cube melts faster on. What is interesting about this is if you're going to do it at home, start by touching the metal baking tray with your hand and the plastic chopping board with your hand. The metal baking tray will feel colder than the plastic chopping board, and if you tried that at home before making your prediction, that might have influenced what your prediction would be. Now let's run the experiment and see which one the ice cube melts faster on, the metal baking tray or the plastic chopping board. You'll notice that it doesn't take long for the ice to start melting on the metal baking tray, but the ice on the plastic chopping board doesn't really seem to be melting at all, or if it is melting very, very slowly. So why does ice melt faster on the metal baking tray than it does on the plastic chopping board, even though the metal baking tray feels colder? Well, these two items are actually at the same temperature because they've been sitting out in the same room this whole time. Metal, though, is a very good conductor, so when you touch something metal, like the metal baking tray, it draws heat away from your hand. The plastic chopping board does not do this to the same extent because plastic is a very good insulator. This is what is having an impact on this experiment. The metal baking tray, because it is a very good conductor of heat, is imparting heat onto the ice cube much faster than the plastic is imparting heat onto the ice cube, because plastic is insulating the ice cube from the surrounding heat. The metal baking tray, however, is drawing heat from the surrounding air and it is putting that into the ice cube. And that is why the ice melts faster on the metal baking tray than it does on the plastic chopping board. Again, this is a really simple experiment that you can do at home to see it for yourself, but you can also test ice cubes on lots of different substances. You could compare it to wood, you could compare it to glass, whatever you have lying about, just as long as you make sure it's a fair test, so everything should start off at the same temperature. But you can try all sorts of different substances and see which one the ice melts faster on. And well done if your prediction was correct that the ice would melt faster on the metal baking tray than it would on the plastic chopping board. Well, that's all for this week. I hope you enjoyed it. If you did, look out for my upcoming video, 10 things you should know about ice, where I do an even deeper dive into some amazing ice facts. If you like this video, please hit the like and subscribe buttons to stay up to date on all future content. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demo and explanation videos I do, here to my 10 things you should know about series, and here to my series on 100 scientists who influenced the world. This has been STEM with Mr. N, exploring incredible ice.